All right, welcome back to Fusion Friday. Today, what we're going to do is we are going to take a look at the simulation space within Fusion, and we're going to do what's called a static study to look at the reaction forces on a couple of different beams. Now, you should have the cross-sectional area dimensions given to you for these three beams, and what you'll notice is that if you inspect all three of these cross-sectional areas, all of them are designed to have the exact same cross-sectional area of 900 millimeters squared. Okay, this is going to give us a couple of different useful things. This is going to show us, one, how to do the static studies within Fusion 360, but it's also going to show us how different shapes actually play a crucial role in the different ways that the static forces affect beams and columns just based on their shape and not on the amount of material. Because all of these beams have the same exact amount of material. The only thing that changes about them is the shape of it. So to do this, once you have your three beams, is the first thing you want to do is actually assign a material to it. So for this test, I'm just going to assign some steel. I'm going to assign some A36 steel. Here we go. Here's my ASTM A36 steel. So I'm just going to take that and drag it to all three of my beams. Now it doesn't change much. The only thing that'll change is the properties of it, and it just makes it more of a defined value than the default steel that Fusion automatically assigns. So once you have the beams, running these static studies is actually quite easy to do. However, the only note is it does require a lot of your computer's power. So if you have a computer that runs Fusion and does not have a very high processing power, I would recommend actually splitting these three up into three individual files and then running three individual static tests. If you have a computer that can handle it, you can do all three of them at once. So what you'll do is you'll go and you'll launch the simulation workspace in the top left corner. So now you'll have a bunch of different studies that you can do in Fusion. And Fusion is very, very helpful for seeing a bunch of different kinds of studies, whether it's frequencies for vibration, thermal studies. There's a whole bunch of different options. But for this one, we're just going to start with the static stress study. In this space, you'll see that you have a bunch of different new tools that you can use. You can create a new study. If, say, we want to do a different loading technique, if we create a new study within that, you'll see that that option comes up again. We can click Create Study. And now we actually have two studies that show up in our browser, one with one set of conditions and the other with another. I am only going to run the one test for this one, so I'm just going to go ahead and delete that, but that is an option, which is really, really handy in Fusion. You can also go ahead and you can change the materials in this workspace as well. The interface menu is a little clunky in this area when you do it, so I would recommend actually assigning the materials in the design space before doing it. The constraints. This is going to be the first important part for our study. So you can add a bunch of different structural constraints to your members. All right, so if we click on structural constraints, you'll see this menu pop up where we have fixed, pin, frictionless, prescribed displacement, and remote. For studying the reaction forces of a beam, when a force is placed directly down on the middle, we typically have one end of the beam is fixed. So I'm going to go ahead and apply a fixed constraint to one end of each of my beams. I'll click OK. And then if I go back over here to my other side, if I pan it around, I'm going to add another constraint where I'm clicking on this one, and this side. And this time, instead of having it be a fixed side, I want this one to be a frictionless or a rolling side. What this allows is as the force pushes the beam down, the beam will still be able to slightly crunch inward as the force is placed downward. So put a fixed end on one side of your beams and a frictionless structural constraint on the other. And we'll click OK. Now all of our constraints have been applied to our model. Now we'll go ahead and go into the loads and we will add a structural load. So there's a bunch of different kinds of loads that we could add. We could add just a regular force. We could add pressure, which is like a continuous load going across. We could add a bending moment across one of these things, and a bunch more. But we could start with just a regular old downward force. So if we click on just the top side, you'll see that this shows that the entire top face of the beam will have some load applied to it. Now, once you do this, what Fusion actually does is it automatically places it towards the center of your load. All right, it's just showing you in multiple different visual ways where your force is being applied, but it will be applied as if it's directly downwards. So we will go ahead and we'll just give this start with a 10,000 Newton force. 10 kilonewton force going straight down, and we'll actually apply it to all three of these surfaces. Again, we can do all of them at the same time. We'll just click OK. And then from there, those are actually all the conditions for our first study. Then once you have all of these reactions and forces applied, what you should see is up here, you can see this little pre-check thing. If we click on that, that will show you that your study has all of the information required to get it set up. So we're good. We could click OK. And then if it says something else, you might have to look at your model and add either another constraint or another force so that the software knows what calculations it needs to run. Then, once you're done with that, you could click on Solve. And this is where the beefy computer is required to run multiple of these at once, because this will take a long time. So we'll just save this as our Fusion Friday. Okay, and now we just have to wait. So this will take a little while, but once this loads, then you'll be all set and good to go. All right, so you'll see that once the study is done, you can click on Close. Now you'll see that the beams, there's some stuff going on here. You know, like there's all these colors and all these different things. All right, you'll see down here in this little scale, you see there's a bunch of different things that you can display. You can display the safety factor, which is what's being shown right now. You can display the stress, displacement, reaction force, strain, and contact force from your beams based on the load conditions that you've defined. So I'm going to start with just the stress. I want to see how each of these beams reacts under different stresses. And you'll see that the beam that's just a square section, there's a lot of stress that is applied on this fixed portion of our beam where we have placed it. You'll notice that the hollow square section has slightly more stress. It's more in the yellow range of around 60 megapascals. But the I-beam is doing remarkably well at handling the stress load. And keep in mind, all of these have the same exact cross-sectional area and force conditions. It's just the shape of the beam that really altered the way it responds to stress, which is super duper interesting. So we could go and we could look at the displacement of it. And again, we see that this just solid square beam is having a lot more of a tougher time handling the loads. Reaction force, same exact thing. We see that a lot of this reaction force is centralized around this square column. But there's a bunch of different other ways that you can use the simulation workspace to test out your designs. But for structural loads, it's a really quick and easy way to see how your different forces will respond under a fixed circumstance.